Hello YouTube! This will be a new devlog series on the game I'm working on. As you can see, it is hex-based. Ignore the graphics, that's just prototyping, just a pack I downloaded. I think 2D painted hex tiles, terrain, or something like that. It's gonna be a World War II based hex strategy game, and I just wanted to document the development, since I think a game is really actually made by the content, not really the code. So showing what I'm doing in the code is not really giving much away. And maybe someone can learn from this, or maybe someone can teach me something, since my experience in C# in the .NET world is quite extensive, but Unity I have only so far scratched the surface of, so there's always new stuff to learn. Anyway, let me give you a quick overview. I basically defined a bunch of scriptable objects to define a terrain type. All of these is of the scriptable object type terrain type, and I have a bunch of them, and each of them is a random tile from the 2D extras package. And they all have 4 different potential sprites which reside in here. A bunch of these from that pack. And in here I have the tiles that correspond to these terrain types. And I will show you in the code how that works in a bit. And I have a free prefab for the map over here and the camera. Camera is very prototype stage, so I'm not really going to go much into that. And in the editor, I've defined a brush that I can use. So let me actually open the, where's that thing? General 2D tile palette. Dock that over here. Come on. Dock. Doesn't want to dock. Okay, fine. I have a new brush in here, a terrain type brush. Seriously, dock, there we go. I have to drag it up there. So a terrain type brush, it's not really actually painting any of the tiles, it's just giving me this drop down with all my different terrain types. And then when I actually paint and have my map selected, I can paint the terrain. However, that works by painting the terrain onto this game map information behavior, which holds a reference to a map, which I can switch out. And that map is actually the data storage, and that is basically a derived or a custom version of what's also in the to the extras package, the game grid information, which can basically store different types, including Unity Engine object types in a list based on, well, kind of in a dictionary, but that's not how it's serialized. So it is kind of a dictionary that takes a certain type of data and a location, and then it stores the data. And that way I can write in there, and then the terrain layer is going to get refreshed, and that thing knows about this information, and it's going to look up inside the terrain type, since that terrain type knows its tile. The terrain layer is going to look that up and paint a random tile corresponding to that terrain type on the map. So I'm not actually, even though it looks that way, painting the actual tile, but I'm painting a data structure which is going to refresh the tile. I'm going to do that this way because I don't want to store tiles on disk on the map. I just want the information on what the terrain type is, the one that is also responsible later for movement and for all kinds of stuff that is actually relevant to the game logic. And maybe in the future I will have some tiles that need to be custom graphic tiles, so I'll figure out a solution for that right when we get there. But for now, I don't really care which forest tile I get when a certain grid position is defined as terrain type forest. I'm also going to do something similar with units. That's coming up next. But that's basically how that works right now. So the main camera doesn't do anything very special. Probably not going to go very much into that because that's very much in the prototype stage. But I basically can go back and forth, and I can zoom in and out. And I also have a script, I think that's also on the camera, where I get the tile coordinates here, the grid coordinates. Still in, what's that coordinate system called? I don't know. The most familiar there is also different coordinates where you have 3 axes going to the different sides of a hexagon. Those I will probably write a conversion between those 2 coordinate systems later, because that other one might make the movement a little bit easier. So let's jump into the code. And let's take a look what I did here. This will be a summary episode, kind of a recap of what I've done so far. In the future, I hope to do it in smaller packets. So the first thing I did, I wrote a couple of object extensions for the Unity engine object type. Since I don't really like the equals operator for null check, since, yeah, the null, in case you don't know, is not really a null. It checks whether the C++ object in the background on the native side has been destroyed. So I have the suspicion that that operator might get removed. Well, not the operator, but the operator overload that Unity defined might get removed in the near future, because once they get to C#8 and all that new stuff comes around with the nullable reference types and all that kind of stuff, I suspect that will go away at some point. It already doesn't really work well with the null coalescent operators and stuff like that. So, and also I want stuff a little bit more explicit. So here I basically use this Boolean auto conversion, the implicit Boolean conversion, and a actual null check. The is operator here is actually checking for null. That cannot be overloaded. So if this is true, it is actually null. That won't get overloaded by Unity. If it's not null, then I check whether it is valid. So whether it is not destroyed, because if this then returns true, then it is because it is actually valid, not because it's not null. And I have the opposite with invalid whenever I want that. And I also have a check reference that in case it is not null, or rather in case it is null or destroyed, in both cases it will give me a actual null, and then with that I can use a null coalescent operator in the proper way. But it's just some helper message to make this null check a little bit more explicit and not fall into a trap and use it wrong. Then we have base classes, both for scriptable object and for components, mono behaviors, in which I just use the nlog package. And I have wrote my static logger in case I need it in a static context, or the actual logger, which gets the context to the actual type, or the actual instance rather. You might wonder why I'm using 1 per instance. The reason is if you actually have a log message, like in here, by the way, I'm also using Console Pro and have that set up properly. If I click on one of these, as you can see, since I have a reference to the actual instance, it's going to show up in the editor and going to highlight that. Not sure why it's not working on the terrain layer. Maybe I'm not actually giving it the proper instance there, but in general, this works. This might actually be a static call. That's no, it isn't. It's just depending on. Sometimes the editor doesn't update, but it did it once. I don't know why it doesn't do it sometimes, but that's down to the editor. In general, however, this gets passed to the actual logger in Unity. And of course, I can define other targets. If you don't know the nlog library, it's basically a .NET logging library where you can set up a bunch of targets. I can quickly show you that in the, where is it? Tools. Control panel. There I can set up some targets. I have an async game log file, an async repeating crash log file, and the Unity console, and I may add a mail target and other stuff. I also have the cloud services hooked up. I also have cloud build hooked up. But I may do a separate video about that in case someone's interested in that. Okay, back to the code. I also have a standard overload for toString, which is just giving back the name, and in case it's a destroyed object, well, if it's null, then I probably can't call toString, but if it is not null and it is destroyed, it's going to give me invalid asset. So that is useful for that. Oh, by the way, about the object extension, someone might know, how can I actually call is invalid on something if it is actually null? Well, it is an extension method, so even though it looks in the code like I'm actually calling this method on the type or on the instance, it is actually just a static method that gets fed a parameter. So I'm never actually, as you can see, calling anything on object, even though it later looks in the code like I'm calling any of these on a potential null. In the actual code that the compiler turns this into, I never actually have a dot behind the object, so that is perfectly safe. I have the same base class for the components for mono behavior. I just call them component because I think that's a better name. Same thing here, except in this case, excuse me, I have called it invalid component. And I have an enumerable extension where I wrote my own for each. I'm not sure whether I'm going to keep that. From what I know, for each loops are not exactly performant. Not sure whether that's going to be relevant since I'm going for desktop applications here, but we'll see how that goes. I can always actually implement this for each extension method with a for loop. So we'll go into that later. I also have an unhandled exception logger here. By the way, let me know what you think about regions in C#. I know that is a little bit of a topic that is splitting the developer base. I kind of like them, but each their own. This thing is basically going to catch, it's going to get loaded after the assemblies are loaded, then it hooks up to the log message received event, and it's basically logging that to the fatal logger, and then it's quitting the application, which it is doing by either actually setting quit with the error code -1, or in case we're running in the editor, it's going to stop the play mode. Not sure whether I'm going to keep that. I'll have to think about that. I don't really like the behavior of Unity that it is swallowing exceptions that happen in mono behaviors, because that might mean some of my game objects are not in a valid state anymore. So I'll have to think about how I'm going to deal with that. But otherwise, the Unity diagnostic services will get notified about exceptions that are unhandled anyway. So I can go to the cloud service and later find that out. But so it's not about locking it and getting notified. That would happen anyway via the cloud diagnostics. This is more about, am I actually leaving the game in a potentially invalid state, or in case something bad happens and it's a bug, I'd rather have the application crash completely instead of leaving the user in a potential state that might corrupt save games or do whatever else potential harm. I will have to think about that and figure out what can potentially go wrong and what I want to keep going or not. So this is not something that is potentially final. I might also hook this up differently and actually do this in the UI and show the error to the user, so he can decide on his own, do you want to go on or do you want to shut down the application if something completely unexpected happens. That's that. And then we have the camera controller. I will not go very much into that because it's basically crap code. These methods are not really great. I'm handling the camera movement where I basically check, are we at the edge of something? Also, if the actual camera is bigger, the camera frame is bigger than the map, then I'm not going to move anything in that direction. I'm going to handle the zoom here. Here I'm checking actually whether the camera is bigger than the map, and in case that is the case, I'm not gonna make sure that we're not going out of bounds, but instead I'm actually gonna center the map on the screen, since I cannot really define the bounds in any direction that would make the camera twitch back and forth, which actually happens to a couple of the camera assets that I found in the asset store, which do not take that possibility into account, that the game area is actually smaller than the camera. If you build a level that is really small, you will have problems with those cameras. Here, the orthographic size, I'm updating that with this formula. That is also something I'm not sure whether I'm going to keep this. This is basically going to make sure that on every resolution, the hex map is actually going to show up exactly the same size. I'm not sure whether that's the right solution. So this is basically not something I'm going to go into detail. This needs massive cleanup. The actual interesting thing is probably the game map, which, as I said, is basically a re-implementation of the grid information class that was on the 2D Extras package. I may rewrite this to a certain degree because I don't really like that this is done by serializing a bunch of lists and then in the serialization callback handler refeeding that into the dictionary and then having all this stuff constantly in memory, when it basically it's once in memory in the dictionary and it is in here after this has been serialized. I mean, I could clear the list after serializing it, but I don't know. I don't really like this. I may do that differently after I find out how to serialize a dictionary. Then the important parts is I can basically erase or store data on any position. I can say the position, the name of the thing. Right now I'm just using the name of the type of whatever I'm storing, since I'm usually going to store only one data of each type. And I can get it for all of the types that are possible. I can set it for all of the types that are possible, and I can reset the entire thing and destroy all the stored data. That gets serialized, and here we have the types for key and value. For the value, you get, in case it's an object, what type it was and the actual data. And for the key, get the position and the name. So this is basically how Unity implemented it. I'm going to modify this probably, but that's basically the information that gets stored on the map. Those are the map assets. Then the behavior I'm using to access that, where I can switch out the map, that's this one, where I am basically I'm actually using the mouse cell position on this one. That's the one that paints in the UI what position I'm on. I'm going to throw that somewhere else later on. Here you also see massive usage of the Odin inspector attributes. If you don't know that asset, you should definitely take a look at it. Serenix Odin inspector, look that up on the asset store. Helps with displaying stuff differently in the inspector. But the important thing is that I basically have my terrain layer here and my map that I can switch out. I have a bunch of methods here that I can also call from the inspector via a button. That's what this is for. I can clear the map. I can set the terrain type here. Here I have methods that are a little bit more specific. The map is very much generic. Here I have the actual stuff that I want to store. I can completely randomize the map based on the available terrain types. I can show you that in a second. And then I can set something, and I always refresh the terrain layer for that position. And that is going to set the actual visible tile all this thing is doing is storing the information on the map. Only the terrain layer is responsible for making something actually visible. This is just for displaying the mouse position. And I have a general refresh button that is going to reload the tiles if necessary. That is going to happen on the terrain layer, where refresh, as you can see, it throws away all the tiles. Then it goes to all the positions that actually have terrain data, refreshes that position, which is basically just setting the tile, and then it goes and compresses the bounds, which is necessary, since if the tile map has actually shrunk because the stored data on the new map is actually smaller, the bounds of the tile map would not be correct, and I'm using those in the camera to determine where the camera should be allowed to move and whatnot. So to figure out where the limit of the actual visible tiles are, I need to recompress them in case I change something here, so the map has the correct size. Because that is actually not something that gets updated. You can clear a map and just have one tile, and if you had previously painted like a 10 by 10 map, it will still be 10 by 10 of size, since that space gets probably allocated in some array or something like that. With this compressing, it's actually reducing it to the actual size. This will only be relevant in the editor. During gameplay, this will basically never happen. At least not on the actual map. So then we have the terrain type, which is a very simple class. It just stores the appropriate tile for this terrain type. This is just to give me in the inspector a list where I can select the appropriate ones, and then I have a property to access that. Then I have a terrain type brush, which is basically also simple. It has a drop down for my possible terrain types. Then this is all Odin Inspector logic, where I can actually get myself a drop down from the values. I'm going to do that a little bit different in the future on how I get those values. Painting is then very easy. This brush also needs to be extended. It currently only supports paint. I also need erase and some other stuff, but I will just get from the grid layout, which this method gets. I'm going to get the component game map information on that grid. Then I'm going to check whether it's actually valid. This I might remove, because if this doesn't work, then it's actually a bug and I probably want the application to crash. Then I set the terrain type on that position, and that will trigger the update in there. The grid information will, on call of this method, trigger the update on the actual layer, on the terrain layer, which is the tile, which updates the tile map. That's why it looks like painting with this is actually painting tiles, but that's just an illusion. That's actually not what's happening. I'm just setting data, and stuff gets refreshed based on that data. And here I'm just, whenever this gets reloaded, recompiled or whatever, I'm setting the terrain type to the first in the list, and I'm refreshing the dropdown. And then I have a bunch of unit tests that is for this game map information. Since I'm planning to refactor this, I basically have a bunch of tests that check all of these methods, whether they are actually storing the right data and retrieving the right data. And that is pretty much it. Let me go back to the editor, and I can give you a little demo of this game map information thing. So I can clear the map, I can randomize the map, and refresh it in case something goes haywire. For example, I could use the normal default brush and get rid of some of these tiles, and if I refresh, they get reloaded based on the data that has been stored. Probably gonna get rid of this brush for now. I can't get rid of it, but I can hide it, since the brush that directly paints certain tiles, I'm probably not going to need that, at least not as I plan it right now. But theoretically, that would be fine, since that's basically exactly the same. What happens when I load a different map, it throws away all the tiles and then it rebuilds them based on the data on the actual map. So the next step will be finding out why this thing is actually not visible when I pick my own brush. Not sure what makes that visible. I'd like to know, so I'm gonna figure that out, because there are some custom implemented brushes here from the 2D package that actually do show that. Not sure why. I'm gonna figure that out. And then I'm gonna start on actually being able to place units here with the same custom brush, probably unit types, and I'm gonna figure out how to do that, since then I can't place tiles and I actually need to place game objects based on this data. So that will be a little bit of work. But yeah, then after that, I need to do a little cleanup, a little more testing, and then we go into actually moving stuff around in actual play mode. Right now, it's mostly editing the map. Later, we'll go into actually playing the map. So that was it for this episode of the devlog. Let me know what you think of my current approach. If you think I do something stupidly or very well, or whether there's a better way to do it, a more efficient way to do it, let me know. And until next time, keep your heads up, folks. I'll see you on the next one.